Hello everyone. Today we are going to discuss Remedial Class 3 Synchronous Machine. In the last lecture we have discussed the armature reaction at and the phasor diagram of the synchronous machine at various loads. Now today we are discussing the OCC characteristic of the synchronous machine, open circuit characteristic. With the armature terminals open, IA open, so that Eg is equal to Vt, or the generated EMF will equal to terminal voltage, will give us the open circuit characteristic of the alternator. Basically, open circuit shows that only field winding is excited and the armature winding is open circuited. So that's why if the armature winding is open, then there will be no current in the armature winding and the IA will become 0. Now let us see how this characteristic can be drawn. With this characteristic, it is possible to find the internal generated voltage of the generator for any given field current. The OCC characteristic of the alternator comes out like this shape, which is linear in the initial stages and becomes saturated after some time. It is drawn between the terminal voltage or generated EMF and field current. Since the generated voltage is equal to the terminal voltage, therefore we can draw both the voltages with respect to the field current. Initially, the open circuit characteristic of the alternator follows a straight line relationship with the field current. But as long as the magnetic circuit of the synchronous generator saturates, the straight line will take a bent shape and the straight line becomes bent after the saturation region of the alternator. This straight line is also known as the air gap line in the OCC characteristic. The second thing we are discussing here is the short circuit characteristic. And the short circuit characteristic is drawn between the armature current and the field current. It is linear relationship between the short circuit. It is linear relationship drawn between the armature current and the field current. To get the SCC characteristic of the synchronous machine, the alternator is rotated at rated speed with armature terminals short circuited, and the field current is adjusted to around 0. The armature current is measured as the field current is increased step by step, which gives the relationship between the armature current and field current, which comes out to be a linear relationship between them. So this is all about the OCC and SCC characteristic of the alternator. Till now we have discussed both the characteristic OCC and SCC. OCC characteristic gives the internal characteristic of the alternator, and it is also a straight line in the initial stages, and after that, after saturation, it becomes bend shape curve. So this is all about for this lecture. Thank you very much.